Okay, so this video is about notes 1, the first part and the first page in the problem set. But I'm really upset I can't be there to especially talk about some really great things that are happening here. But we'll talk about them next class. This is especially awesome, especially if you sing it to yourself. So this unit is about circuits. So like our last lab, lighting the light bulb with the single battery, we're going to talk all about different types of circuits, what's actually flowing through wires, which is just electrons, but what does that depend on? And how do we describe all those things in physics? So first thing to discuss that we're going to talk about next class when we do our first lab is about a battery. And really all a battery is it's a bunch of stuff in there, part of which is an acid. That's why when batteries like open, or if you've heard battery acid, or you're not supposed to just throw away a battery. You're supposed to put them into separate and special recycling areas. And it's because they have these chemicals inside of them that cause a positive charge to build up at one end and a negative charge to build up at the other end, thus positive and negative side of the battery. Now, the charge buildup of this results in a difference, right? These are different charges, and they have different potentials that we call voltage, which is why if you look on batteries, you'll see standard batteries are 1.5 volts. You can also buy 9-volt batteries. Those are the ones that kind of look like this with like two things kind of coming up. Those are the ones where if you lick them, you can really feel something a lot more than the other normal ones. But anyways, and that charge difference, nothing's going to happen to it unless you connect it in a circuit. Now, you will have a little bit of movement through a battery, but there's other things in there to prevent too much movement from going on. So when we say movement, what do we mean? We mean electric current. The letter for electric current is capital I, and it's just a flow of charge. What is that charge? We know that electrons are what are doing the moving. Protons don't move. And positive in a battery and in a current is really just thinking about lack of electrons. So kind of annoying thing in physics is that we draw conventional current when we're drawing where the electrons are going, or where the current's going, I should say. We draw it from positive to negative. That's how we draw current. However, the current's not actually moving in that direction because the electrons are what are moving, and they move from the negative end where they are to the positive end. It's a little bit annoying, and just think about it as opposite, but the drawing that we do is positive to negative. So for example, if I were to like draw a current here that's attached to a battery, it's the positive and that's the negative. The way I'd draw the current would be this way, from positive to negative, even though, so I could label that as I for current, even though I know that the electrons are moving in the opposite direction. So formula for current. Current is I, that's our letter, and the unit for electric current is in amps. Make sure you write that down right now. Capital A for amps. It's like a speed, really. So like how velocity is change in x, or distance, divided by a change in time. Current is a speed, not of distance, but of electrons, and specifically of charge. So Q is charge from last unit. We know that charge is in coulombs, capital C. Time is always in seconds. And remember that the triangle is just saying a change in. So a question could say that 5 electrons move in, or, 5 coulombs of charge moves in 2 seconds. So it's just talking about that change in time and change in the amount of charge that is moving. So I want to pause at this point to go into the problem set and practice the first two. So the first two are specifically about current. So remember that current is I. So we'll solve number one. If 25 coulombs of charge, so charge is 25, flows by in 60 seconds, time is 60, what is the electric current? Current is I. So our equation is just that I equals charge divided by T. When I write the equation, I usually just ignore the triangles, the change in, because it's assumed. So 25 divided by 60, and we get 0.417 amps. Something to know about current, 1 amp is a lot of current, so we will have smaller numbers for our current, decimals usually. How long does it take for 50 coulombs of charge? That is a lot of charge. These are kind of gigantic numbers here. To flow by if the current is 4 amps. That's a pretty big current there too. And we're solving for how long? In seconds. Solving for T. So I is Q divided by T. If I plug in here, my I is 4, my Q is 50, my T is what I'm solving for. At this point, you could decide to cross multiply or just get T out of the bottom. So I'm going to multiply both sides by T, get that out. Now I have 4T equals 50. I divide by 4 to both sides. And we could do that in our head pretty easily, but I'll just show you guys here too. So the time would be 12.5 seconds. So the math of current is pretty simple. Just remember that I is current, it's in amps, Q is charge, and T is time.